To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students. So I am going to continue the lesson current electricity. In the previous chapter we discussed Ohm's law. What is Ohm's law? Where at constant temperature the current is proportional to potential difference across a conductor. And when you from that relationship, if you get an equation, you get potential difference divided by current. And that is a constant, and that constant is what we call as resistance of the conductor. So from that relationship and the equation, we come to the final equation where you get the equation as V equals IR. V is the potential difference, I is the current flowing through the conductor, and R is the resistance of the conductor. And you all remember, students, the resistance is measured using the SI unit ohms, because the Ohm's law was actually proposed by the scientist, a German scientist, George Simon Ohm. So there, the instrument or the device used to measure resistance is also known as ohm meter. And the symbols, you all know, symbol for ohm. So the relationship is V equals IR. So I told you all we will be discussing about resistors further. So here we will try to understand. If there is a resistor, you all can remember there was a rheostat, a variable resistor that we used in the activity in the previous chapter. So like that, there are different types of resistors, and conductors also have resistance. And there are factors that affect the resistance of either a resistor or a conductor. So we will be looking at the factors affecting the resistance of a conductor. Factors affecting the resistance of a conductor. The resistance of a segment of a conductor depends on the following factors. So if we look at the factors, now here it will depend on the length of the segment of the conductor. Then we have the area of the cross section of the segment of the conductor. I will write the factors first and explain it to you all. Then the third one is the material composition of the conductor. Now, if we try to understand all three factors, the resistance of a segment of a conductor depends on the following factors. You can write them in any order, no problem. Length of the segment of the conductor, that is the length. Then area of the cross section of the segment of the conductor. Material composition of the conductor. Now we will try to understand these. Let's say you have a conductor, a conducting wire like that. So here, if we consider this as copper conductors. Now, if you take the first two, 1 and 2, you can see their length is equal. But if you look at the area, This area, that is the cross-sectional area, is smaller. This area is larger. So there the resistance will vary. The way the current flows through these two conductors, although they are both made up of copper, their lengths are equal, but the area of the cross section is different. So because of that, the resistance will be different. So here it is the area. Area of the cross section. Then if you take the third one, now if you assume or if the area of the cross section of 1 and 3 are equal, you can see from the diagram the length is different. Then also the resistance will be different. The same way, if we take two conductors made up of different materials. Now let's say the fourth one. Now 3 and 4, same length, same area of cross section, but let's say one is copper, the third one is copper as we mentioned before, and this one we will say is made up of iron or steel. Then also the resistance will be different. So if this is steel, then it is the material. So the area of the cross section, then you can see the length, and here it is the material. Material, and before that these two, or it is actually 1 and 3 length. So those are the factors that affect the resistance of a conductor. And why do we say material composition? Now if you remember in the previous chapter also, we discussed nichrome coils. Now nichrome is made up of nickel and chromium. So two different metals mixed together. So they are the composition. Now if you take steel, you can have different ratios, different components present. In addition to iron, carbon, there can be other substances. So the material composition is very important. It can be a pure metal, a pure conductor, or it can be a mixture of metals. So basically the material composition of the conductor. So those are the three factors. The length of the segment of the conductor, area of the cross section of the segment of the conductor, and the material composition of the conductor. Three factors. Now we will do an activity to understand how these three factors affect the resistance of a conductor. So with that, I'll move on to the activity. Activity. Investigate the influence of each of the above factors on resistance. So to do that, we need all these materials. So here, first one, nichrome wires. So here we will need nichrome wires of different thicknesses. Then we need copper wire, and then we need iron wire. So here we will be changing the thickness and the length, and we have three different materials. So basically we will be changing the thickness of the nichrome wires, and we will be using different lengths of wires as well. Then we need to have dry cells or batteries. Dry cell or batteries. Then we need an ammeter. Now you all know the function of an ammeter, to measure the current flow across the conductor. Then we need a switch to turn on and off the circuit, and also we need a wooden board. what we will be doing is, we will be fixing a conductor to the side of the wooden board. Then like I said, we'll be using different thicknesses, different lengths of all these three conductors combined together. Combined in the sense, one after the other, we will attach those conductors onto this board. And then we will connect the circuit. I will show you the diagram. And then with each conductor, we will measure the current flow using the ammeter. Then you will understand the difference in resistance and how the three factors, the length, the area of the cross section and the material affects the resistance and therefore the current flow across the conductor. So I'll move on to the next slide where I will discuss the procedure in detail. So procedure. First we'll look at the diagram. Here as you can see students, this is how we connect. We have the batteries connected in the correct manner, positive, negative, positive, negative. Then to the positive terminal we have the switch connected. Now here you can see this is the wooden board. Now this is the wooden board. And here you can see on this side we have a particular conducting wire that is connected with this conducting wire. So that is this part that is not going to be moved. So this is connected. Then we have the different materials, the different conductors. Now here you can see they are numbered 1 to 7 and you can see from 1 to 5 the length are the same. The length of the conductors is the same. But from the diagram you can see 1, 2, 3 the cross-sectional area of the cross-section is different. One is a more broader cross-section. 2 is a medium size, then 3 is a thin cross-sectional area. So 3 different cross-sectional areas, same length and it has to be the same material. When we are testing for one factor, the other 2 factors have to be constant. So first 3, only the area of the cross-section is different, length is the same, material is the same. Then if you take 3, 4 and 5, again you can see the length is the same, but there the cross section is also the same. 3, 4 and 5 cross section is the same, area of the cross section is the same, but the materials are different. We will be using nichrome, copper and iron. So material is different or material composition is different, but the length and the area of the cross section are same. Then if you take 5, 6 and 7, the material will be the same. The area of the cross section will be the same, but the length you can see are different. 5, 6 and 7. That is how we are going to combine all the factors. 1, 2, 3, different area of cross section. 3, 4, 5, different material composition. 5, 6 and 7, different length. So all 3 factors are tested together. Then on this side, you can see although the bulb was not mentioned with the materials, we have mentioned the ammeter. So why do we use a bulb? To observe that there is current flow. You can observe that using the ammeter also. There will be a deflection, there will be an ammeter reading. But both of those confirm the current flow. You can also observe the brightness. If there is a difference in brightness due to different amount of current flowing through the circuit, you can notice the difference there. You can get the ammeter reading, so you know the current flowing through the circuit. So after everything is connected, what we do is, now you can see this part of the wire X that is not connected anywhere. It's just on the board. So what we do is, we connect this X to the first wire, end of the first wire. Then you observe the bulb and the ammeter reading. Then you switch the circuit off, remove the wire, connect it to the second conductor. Again switch on, observe the brightness and also get the ammeter reading. Switch off, connect it with the third conductor, repeat the procedure. Likewise, for all the 7 conductors, you have to repeat the procedure and you need to get the ammeter reading. From that, you can understand the effect of all these 3 factors on the resistance of the conductor. That is the procedure. We will read the procedure again. So here you can see, connect the circuit shown in figure using the items above. Connect the terminal X to the end of each conductor and record the current passing through each conductor. In the above figure, the numbers indicate the following segments. So like I told you all, the numbers. First one, nichrome wire with the largest cross-sectional area. Second one, nichrome wire with the medium cross-sectional area. And third one, nichrome wire with the smallest cross-sectional area. So like I said, the first 3 are similar. We are testing the effect of cross-sectional area. So here, length and material same. Material same. You all know that. Then 3, 4, 5. You can see nichrome wire with the smallest cross-sectional area. Then thin copper wire, thin iron wire. So I told you all, why thin? Because they need to have the same cross-sectional area, same length, but the materials are different. So 3, 4 and 5. 3, 4, 5. Same length and cross-sectional area. And finally, 5, 6 and 7. All are iron wires. You can see thin iron wire, 6 and 7 iron wires with unequal lengths. So 5, 6 and 7 all are iron wires, same material, same cross-sectional area, but the length is different. So that is something you have to remember. 5, 6, 7, same material. So that is iron and same cross-sectional area. Then you know what to do. Connect the circuit, connect the point X of the conducting wire to each conductor, get the ammeter reading. So then you will have a set of data. From those information, you can understand how the 3 factors affect the resistance of a conductor. So I am sure students, you all can understand this activity clearly. So let's go to the lab and do the activity now. Okay students, so now I am going to do this activity in order to understand the factors that affect the resistance of a conductor. Or we will try to see how the different factors. There are 3 factors that we discussed. The cross-sectional area of the conducting segment. Then the length of the conductor, the length of the segment of the conductor, and also the material composition of the conductor. So to do this activity, we need the power supply. So I have the dry cells here, all connected in the proper manner. Then you can see the positive terminal of the dry cell is connected to the positive terminal of the ammeter, and the negative terminal of the ammeter is connected to a bulb. Then the other end is open here. I'll be connecting it with the conductor. The same way this side. The negative terminal of the batteries is connected to the switch. So now I have this open end which I can connect with these nails on this board, and on this side also I have this end that is connected to the bulb that can be connected with these different nails. So then these are the conductors. Now You can either have a metal rod and tie the wires, conducting wires, the metal wires to that on one side so that it will be fixed. Otherwise, we can have nails like this on either side so that we can connect the two crocodile clips and use the different conductors. So now here you can see the conducting wires are labeled. Now the number 1, 2, 3. All of these are made up of the same material, nichrome. And also here you can see they have the same length. So material is the same, length of the conductor is the same. Only difference is the area of the cross section or cross-sectional area of the conductor. Now this one, the first one is the most thickest wire, second one is a little bit more thinner, and the third one is very thin comparatively. So the first one has the highest cross-sectional area, the second one has the medium cross-sectional area, and the third one has the lowest cross-sectional area. Then if we take the conducting wires 3, 4 and 5, you can see they have the same length and they have the same cross-sectional area, but they are made up of different materials. 3 is nichrome, 4 is copper and 5 is iron. So different materials. Then you take the conductors 5, 6 and 7. They have the same thickness. They are made from the same material. Everything is iron. Only thing is the distance, the length is different. 5 is the longest one, 6 is shorter than that, and 7 is the shortest conductor. So now what I'll be doing is I will connect this end to this nail and this end to that nail for one conductor. Then we'll close the switch, and at that time look at the ammeter reading and the brightness of the bulb. That is what you need to observe. So here I am going to connect this end here and this end here, and we will turn on the switch. When I turn on the switch, you can see somewhat bright. We have to compare and you have to look at the ammeter reading. The ammeter reading is 0.4. So I will note that down, 0.4. Just observe the brightness. I will turn it off. Then we will connect it with the second set of wires with lesser cross-sectional area. Now again, I am going to close the switch. When I close the switch, now you can see. So here, look at the ammeter reading. What is the reading? 0.3 amperes. 0.3 amperes. And if you can remember, the brightness is somewhat lesser than the previous brightness. A little bit less. So I will put 3 ticks for the first brightness, 2 ticks for the second brightness. Now I am going to turn the switch off. Then the third conductor, the lowest cross-sectional area. Now we will close the switch, complete the circuit. Now can you all see? The bulb it lights but very less brightness. And look at the ammeter reading. What is the ammeter reading? The ammeter reading is 0.2 amperes and very less brightness. So now you all can understand what happens there. The first 3 conductors are made up of the same material, same length, but what happens? The cross-sectional area is different. When the cross-sectional area is high, the highest cross-sectional area, the current flow was 0.4 amperes and the brightness was highest. When cross-sectional area decreased, current decreased and the brightness of the bulb decreased. So from that you can understand when the cross-sectional area is high, there is more current flowing through the conductor. That means the resistance of the conductor is less. So now we are trying to understand the factors that affect the resistance. Cross-sectional area more, resistance is less. Cross-sectional area is less, resistance is more. So that is how the cross-sectional area of the conductor affects the resistance. Now we will observe the next 3 conductors. Again, third one also we did, but just to compare, we will start from that. Now here you can remember we have a very light brightness, very less brightness, and 0.2 amperes with nichrome conductor. Now I am going to connect it to the fourth one, that is the copper conductor. Now copper, when we close the switch with the fourth conductor. Now look at the brightness. Very bright, and look at the ammeter reading. So the ammeter reading is 0.4 and also very, very bright. So now I am going to switch this off and connect it to the fifth conducting wire. That is made up of iron, the same length but the same cross-sectional area. So 3, 4, 5, same length, same cross-sectional area. Only thing that is different is the material. So I have written down the value. Again, I am going to on the switch. Now here you can see the brightness is somewhat less, and look at the ammeter reading. 0.3 amperes. So 0.3 amperes and less brightness. Now if you look at the three conductors, 3, 4 and 5, nichrome, copper and iron. You can see the area, cross-sectional area is the same, length is the same. Only thing that is different is the material. Through copper, the brightness was the highest and 0.4 amperes. Highest current flows through copper. That means the resistance of copper is the lowest compared to the 3. So after copper, if you look at it, it is iron, 0.3 amperes. So that has a little more resistance, and nichrome has the highest resistance by 0.2 amperes, and the brightness was the least. So now you all can understand. This factor, that is the nature of material or the material composition of the conductor, is actually known as resistivity of the conductor. So that is the second factor that affects the resistance. That directly depends on the material or the resistivity of the material. Then we have the wires 5, 6 and 7. All of them are made up of the same material, iron. They have the same cross-sectional area, but they have different length. Again, just to compare, I have already connected it to the fifth conductor, that is the iron wire, iron string. Now you can see the brightness and the ammeter reading 0.3 amperes. I will switch it off, connect it to the next wire, sixth one. Can see here. Then if I close the switch, now the length has decreased. So here the brightness is more. Look at the ammeter reading 0.4. So 0.4 and the brightness is also more. So I'll switch it off and then we will connect it to the shortest conductor made up of iron. So now look at the brightness. It's very much brighter, and look at the ammeter reading 0.5 amperes. So here I will turn the switch off, 0.5 amperes and very high brightness. So there, if you compare the three conductors 5, 6 and 7, same cross-sectional area, same material iron, but the length is different. When the length became shorter, the shorter wire, the brightness was more, current was more. That means when the wire is short, the resistance is less. The longest wire, less current, 0.3 amperes, and the brightness was less. That means the resistance of the longest wire was the highest. So from that you all can understand. When the length of the conductor increases, the resistance increases. So we wanted to observe the factors that affect the resistance of the conductor. When the cross-sectional area increases, the resistance decreases. Then material composition determines the resistance. That is what is related to resistivity of the conductor. And then when the length decreases, the resistance also decreases. Those are the three factors and the way they affect the resistance. I'm sure you all can understand that clearly. Okay, students. So you observe the activity clearly. We used different wires. The first three wires, they were all nichrome wires and they had the same length. Only difference was the difference in cross-sectional area. There you got the readings. Then after that, we had the same length, same cross-sectional area, but different materials. Nichrome, iron and copper. Then thereafter, we had the iron wires, same cross-sectional area, but different lengths. So there were 7 conductors and we got the ammeter reading and also you saw the brightness of the bulb. And you can remember when I noted down the observation, I used ticks. More ticks, more brightness. So I will write down the observations here first. Now conductor 1, we got the current ammeter reading 0.4 amperes and the brightness, I said ticks, it was the brightest between 1, 2 and 3. Then for the second one, current was 0.3 amperes, the brightness was less, and the third one 0.2 amperes, the brightness was even more less. So from these three, what can you understand? The cross-sectional area decreases. This was the wire with the highest cross-sectional area, then medium cross-sectional area and the smallest cross-sectional area. So when cross-sectional area decreased, the current flow decreased and the brightness of the bulb decreases. So from that, what can you understand? Current decreases means the resistance increases. So from that, you can understand when cross-sectional area decreases, the resistance of the conductor increases. That is one thing you need to understand. We will be writing down the conclusion again as well, but once I will write it here also. So from 1, 2, 3, what can you understand? Cross-sectional area, channel area of the conductor decreases. Then the resistance increases, the current flow decreases, brightness of the bulb decreases. That is for the first 3 sets of observations. Then, so that is for these 3. Then we have the fourth one. Fourth one, there was a current flow of 0.4 amperes and the brightness was very high. And then fifth one, 0.3 amperes, the brightness was somewhat low. So here this was nichrome, this was copper, and this was iron. So out of these 3, you can see when we use nichrome wire, very less current flow, only 0.2 amperes and the brightness is also less. So that means nichrome has very high resistance. Then you can see the next one out of these three, 0.3 amperes for iron. Brightness was also medium. So that means the resistance of iron is less than that of nichrome. So there is a little bit more current flow and more brightness to the bulb. Then if you look at copper, the amount of current flow is the highest and the brightness is also the highest. So from that you should understand that copper has the lowest resistance out of these three materials. But from all these observations, you all have to understand that the resistance of a conductor depends on the material composition of the conductor. So materials are different, nichrome, copper and iron. Then the resistance is different, therefore the current flowing through them is different. So the difference in material composition is related to resistivity of the conductor. We call it the resistivity of the conductor. The material composition leads to resistivity of the conductor. So if we consider 3, 4, 5, difference in material leads to difference in resistance. That is known as resistivity. And also, if you consider the resistance, nichrome highest, then iron, and then copper. So copper is a very good conductor. That is why we use copper wires as conductive wires mostly. Nichrome is a conductor but with high resistance. So usually when nichrome is used, there is high amount of heat generated. We discussed that when we discuss Ohm's law activity also. So because of that, we use nichrome in devices, electric appliances, where there needs to be a lot of heat produced. Because against resistance, current is used up and that current is converted to heat. So that is the observation of the next three activities. Then the last set of activities, that is 5, 6 and 7, the same conductor, iron, same cross-sectional area, but the length are different. So 5, 0.3 amperes, 6, 0.4 amperes, and the brightness was more, and 7, 0.5 amperes, the brightness was very much higher. So what do you see? Here in these three, length decreased. 5 had the longest wire, 6 had a medium length conductor, and 7 had the shortest conductor. So when the conductor became shorter, there was more current flow. So what can you understand there? When length decreases, resistance also decreases. That is why the current flow is more. That is the next one. So here, the next one, 5, 6, 7, the length of conductor decreases, then the resistance decreases, the current flow flow increases, brightness of the bulb increases. So this is something you all need to understand and keep in mind, students. So these were the observations of the activity. From the first three observations, you could understand cross-sectional area of the conductor decreases, then the resistance increases. That will be the conclusion, first conclusion. Then the current flow decreases and the brightness of the bulb also decreases. Then from the next three set of activities, or 3, 4 and 5, difference in material leads to difference in resistance. So that is what we will be calling as resistivity, and resistance of nichrome is higher. That means resistivity of nichrome is higher, iron is little less, and copper has the least resistivity and therefore the least resistance. Then the last set, 5, 6 and 7, the length of the conductor decreases, then the resistance decreases, the current flow increases and the brightness of the bulb increases. In these, students, you all can see in all the three sets, one activity becomes common. Here 5 is common to both these activities. For the first and second set, 3 is common. So that you all have understood. So those are the observations. Again, I will write the answers to the questions given under conclusion in the next slide. So from that, you will understand very clearly the three factors that affect resistance of a conductor, length of the conductor, cross-sectional area of the conductor, and the material composition of the conductor. And already you have understood how they affect the resistance of the conductor. So with that, students, I will move on to the next slide. So the conclusion. From the observations, you all were able to understand how the three factors affected the resistance of the conductor. So you can remember, students, the first three conductors, nichrome wires of the same length. But what was the difference? The area of the cross-section or the cross-sectional area. So here the question is, what conclusion can you draw from the readings obtained for the wires 1, 2 and 3? What can you come to? What is the conclusion? Now you know the first one with the largest cross-sectional area, the current flow was more. Second one, less cross-sectional area, current flow was less. And the third one was the thinnest cross-sectional area or the smallest cross-sectional area, and the current flow was the least. So what can you say? When cross-sectional area increases, the current flow increases. That means when cross-sectional area increases, the resistance decreases. That is the conclusion. So the conclusion for 1, 2 and 3, the resistance and decreases with the increase in area of the cross section of a conductor. So that is the conclusion from the first three conductors, the wires 1, 2 and 3. Then what did we have? What can you conclude from the readings for the wires 3, 4 and 5? What were they? 3, 4 and 5, they had the same length, they had the same cross-sectional area, but 3 was a nichrome wire, 4 was a copper wire, and 5 was an iron wire. And their resistance was different. How? the current flowing through those conductors varied. How did they vary? There was more current flowing through the copper conductor. So that means the copper conductor has the least resistance. Then there was a little less current flowing through the iron wire. So iron wire has a resistance more than copper wire. But there was a very small amount of current compared to the other two flowing through the nichrome wire. So that means nichrome wire has more resistance. So what can you conclude from this? The material affects the resistance of the conductor. So that is the conclusion. The material of the conductor, affects the resistance. So resistance, copper, iron and nichrome. So this is the reason we mostly use copper as the conducting wire in the household circuits. You all know at home all the current wires, they usually are made up of copper. Then we have nichrome in what? I told you all before also. In devices, electrical devices that are used to produce heat. Usually the electric iron. Electric iron has a nichrome coil. Because of its high resistance, most of the current is converted to heat. So devices, instruments that need to produce heat use nichrome wire because of its high resistance. Then iron has resistance in between copper and nichrome. Then what can you say from the readings for the wires 5, 6 and 7? What were the wires 5, 6 and 7? They were all iron wires. They had the same cross-sectional area, but they had different lengths. So if you remember, 5 was the longest wire, 6 was a little shorter, and 7 was the shortest wire. And if you consider the current flow, there was very less current flow through 5, the longest wire, a little bit more current flow through 6, a little short, and through the shortest conductor, there was more current flow. So from that, what can you say? When the length decreases, the current flow is more. That means when the length decreases, the resistance also decreases. That is the conclusion that we can get. Because always when the resistance is less, there is more current flowing through it. So there you can say, so we can say when the length of the conductor decreases, the resistance decreases. So basically, less shorter conductor, less resistance. Longer conductor, more resistance. So short conductors will allow more current to flow when the potential difference is constant. And long conductors will let less current to flow through them because the resistance will be high. So if we look at all three factors, the resistance decreases with the increase in area of the cross-section of a conductor. That is the conclusion from the first three conductors, 1, 2 and 3. Then from the conductors 3, 4 and 5, you all know the material of the conductor affects the resistance. And you all were able to understand that the resistance of copper was the lowest, iron a little bit more high, and nichrome had the highest resistance. And what can you say from the readings for the wires 5, 6 and 7? When the length of the conductor decreases, the resistance decreases. So those are the conclusions that you can get from the activity. I am sure you all saw the observations and you all understood these conclusions clearly. So with that, students, I will move on to the next slide. So according to activity, it will be clear that the current flowing in each of the above instances are different. That you all saw. The reason for this is the differences in the resistances in each instance. According to this activity, 3 main factors that affect the resistance of the conductor can be stated. So we have already stated the 3 factors. What are they? First one, cross-sectional area. Area of the conductor. Or you can say area of the cross-section of the conductor. Same thing. Then the second factor, length of the conductor. Length of the conductor. And the third one, material of the conductor. Material of the conductor. So 3 factors. Cross-sectional area of the conductor, or you can say area of the cross-section of the conductor, length of the conductor and material of the conductor. So those are the 3 factors that affect the resistance of a conductor. In the next slide, again we will summarize how these 3 factors affect the resistance of a conductor. So how each of them affects the resistance is mentioned below. So this is how it happens. First one, we can say resistance decreases when the cross-sectional area increases. So cross-sectional area increases, resistance decreases. Then resistance increases when the length of the conductor increases. So resistance increases when the length of the conductor increases. And the third one, resistance depends on the nature of the conducting material. And this quantity is known as resistivity. Resistivity. So we give a term or a quantity that is defined as resistivity. So resistivity of different conductors differs because they are made up of different materials. So if you compare copper and nichrome, resistivity of nichrome is very high. That is why the resistance is high. Resistivity of copper is less or low. So that is why the resistance of copper is low when the other two factors are same. So if you take two conductors, copper conductor and nichrome conductor of the same length and cross-sectional area, the resistivity of nichrome is high, resistivity of copper is less. Because of that, resistance of nichrome is high and resistance of copper is less. I'm sure you all can understand that. So these are the three factors and how they affect the resistance. Resistance decreases when the cross-sectional area increases. Resistance increases when the length of the conductor increases. And resistance depends on the nature of the conducting material. And this quantity is known as resistivity. So here a factor, resistivity. So you all have to remember that. Now for cross-sectional area, you can compare two pipes. Now earlier also we compared the flow of electricity to flow of water. So when the cross-sectional area is large, you can imagine that as a large pipe, and cross-sectional area small, you can imagine that as a small water pipe. And if there is the same amount of water, I'm sure you all know water can flow easily through the large pipe, the pipe with the large cross-sectional area. The same goes for electricity. So when the area, cross-sectional area of the conductor is larger, the resistance is lesser, so current flows easily. But if it is a long length, if the length is more, then throughout the conductor there is resistance. It has to pass through all that resistance. So when length increases, the resistance of the conductor increases. And again, material, it is the resistivity. So the three factors and how they affect the resistance. I am sure you all can understand all these very clearly. The three factors and how they affect the resistance of a conductor. With that, students, I am going to end this chapter, and in the next chapter also I will be discussing about resistors and how they are connected in circuits.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.